Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on September 23, 2025, just yesterday. The big result is striking. By dropping proprioceptive state inputs and relying on vision with a relative end-effector action space, success jumps from 0% to 85% for height generalization, and from 6% to 64% for horizontal generalization. The paper is titled, "Do You Need Proprioceptive States in Visuomotor Policies?" And as we will see, the implications for robust robot control are compelling. In short, the study shows that vision-only policies with dual wide-angle wrist cameras generalize better, overfit less, and transfer across robot bodies with improved data efficiency. So, Figure 1 makes the takeaway concrete. Vision-only policies succeed when the robot acts in a relative end-effector space, and the cameras provide full task observation, which means task objects stay in view at all times. The overview grid contrasts camera setups and state input. The top row with normal wrist cameras shows weak height and horizontal generalization. The bottom row with wide-angle wrist cameras and without state shows strong generalization in both directions. Alright, Table I reports success rates for height generalization in the pick-a-pen task. With state and normal wrist cameras, the policy passes in domain but collapses out of domain because it latches onto absolute poses. Simple state hacks or added noise restore out-of-domain success, which signals the state as the bottleneck. Removing state with dual wide-angle wrist cameras maintains perfect in-domain performance and strong out-of-domain robustness. So while Table I highlighted the gains, Figure 2 explains the mechanism. Dual wide-angle wrist cameras provide full task observation, which means the robot consistently sees the object and the space under the gripper. The left panel with a normal wrist camera can miss the target because the view is narrow. The right panel with two wide lenses expands coverage, so identical visual observations map to the same relative end-effector move. Alright, Figure 5 shows that vision-only policies with dual wide-angle wrist cameras generalize far better than state-based ones across 3 pick-and-place tasks. Horizontal generalization means the robot succeeds when objects shift sideways, not just up or down. The left panel reports pick-a-pen where height success reaches 0.98. The middle and right panels echo the pattern, with strong gains in both height and horizontal directions because the policy cannot rely on absolute poses. So, Figure 5 showed big gains with vision-only control. Table IV reports spatial generalization across camera setups and makes the mechanism explicit. Fuller task observation, meaning the object stays in view throughout the motion, drives robustness. Dual wide-angle wrist cameras without an overhead reach 1.0 in both height and horizontal generalization. Configurations with normal lenses or fewer cameras trail because they miss key views and create blind spots that confuse the policy. Wrapping up, 2 takeaways stand out. Vision-only policies that use relative end-effector actions and dual wide-angle wrist cameras generalize far better and overfit less, and they also train and transfer with fewer demonstrations. The broader implication is simpler, more scalable robot deployment across embodiments with less calibration fuss. That is it for the AI Research Roundup. I am Alex. Thanks for listening.